Hello, and welcome to this lesson on carboxylic acids. In today's lesson, we will firstly understand what a carboxylic acid is. We will then explore the structure and general formula of carboxylic acids. Finally, we will learn to identify and name different carboxylic acids. So far, you are familiar with the general properties of alkanes, alkenes, and alcohols. You've learned how alkanes are simple hydrocarbons with single bonds, alkenes contain double bonds, and alcohols feature a hydroxyl functional group. Building on this foundation, today's lesson will advance our chemical understanding by introducing carboxylic acids. These compounds add another functional group to our repertoire, allowing us to grasp more complex chemical behaviors and interactions. Let's get started. Carboxylic acids are a homologous series of organic compounds that contain a functional group known as the carboxyl group, COOH. This group consists of a carbon atom double bonded to an oxygen atom and also bonded to an OH group. The carboxyl group is the defining feature of carboxylic acids and is responsible for their acidic properties, which we will explore in further detail in an upcoming lesson. Carboxylic acids are represented by the general formula CnH2nCOOH, where N represents the number of carbon atoms in the molecule, excluding the carbon in the COOH group. For example, when N equals 1, the molecular formula would be CH3COOH, which is ethanoic acid. Carboxylic acids are named based on the number of carbon atoms they contain, similar to other organic compounds, but with the suffix oic acid. Methanoic acid, also known as formic acid, is the simplest carboxylic acid. It contains one carbon atom and has the structural formula HCOOH. It's found in the venom of some ants, hence the name formic acid, which comes from the Latin word formica, which means ant. Ethanoic acid, commonly known as acetic acid, has two carbon atoms. Its structural formula is CH3COOH. This is the acid found in vinegar, which gives vinegar its characteristic sour taste and smell. It's widely used in the food industry as a flavoring and preservative. Propanoic acid contains three carbon atoms. Its structural formula is CH3CH2COH. This acid is used as a preservative in food to prevent mold growth. Finally, butanoic acid consists of four carbon atoms and has the structural formula CH3CH2CH2COOH. It's responsible for the unpleasant smell of rancid butter and also used in the creation of various pharmaceuticals. By understanding the fundamental structure and properties of carboxylic acids, we can appreciate their versatility and importance in both natural processes and industrial applications. This will also enable us to predict and analyze their behavior in various chemical reactions, enriching our overall knowledge of organic chemistry. In today's lesson, we delved into the homologous series of carboxylic acids, a group of organic compounds characterized by the carboxyl functional group, COOH. We learned that the carboxyl group consists of a carbon atom double bonded to an oxygen atom and single bonded to a hydroxyl group, which significantly influences the properties of carboxylic acids. We then examined several common carboxylic acids: methanoic acid, ethanoic acid, propanoic acid, and butanoic acid, noting their structure and applications. This lesson has provided a comprehensive understanding of the structure of carboxylic acids, which will serve as an excellent foundation as we delve into their properties and behavior in the next lessons. Watch the rest of the GCSE chemistry course at Sophos Education.